Something just happened at Tesla that almost no one is talking about. But it could quietly reshape the entire global supply chain. And at the center of it all is something deceptively simple. A shift from 12 volts to 48 volts. A change that sounds boring, technical, almost insignificant, but in reality acts like a silver bomb dropped right into the heart of modern manufacturing. Because this is not just about better wiring or improved efficiency. This is about materials, costs, scale, and control. And once you see what this change really means, it becomes clear why legacy automakers, suppliers, and even mining companies are suddenly paying attention. For decades, the automotive world has relied on a 12-volt electrical architecture. It powered everything from headlights to infotainment systems, window motors, sensors, and control units. It became a global standard because it worked, it was cheap, familiar, and reliable. But as cars evolved, especially with the rise of electric vehicles packed with computers, sensors, cameras, and autonomous features, that old system started to show its age. More electronics meant more power demand, and meeting that demand with 12 volts required thicker copper wires, heavier harnesses, and increasingly complex layouts, which added weight, cost, and inefficiency. Tesla looked at this and decided not to patch the problem, but to break the standard entirely, moving to a 48-volt architecture that changes how power flows through the entire vehicle. And here's where the silver bomb begins to tick, because voltage and current have a simple relationship. Higher voltage means lower current for the same power, and lower current means thinner wires. Less heat, less energy loss, and dramatically reduced material usage, especially copper and silver. Silver in particular is critical because it's used in electrical contacts, connectors, and high-performance components, where efficiency and reliability matter most. Now imagine Tesla producing millions of vehicles that suddenly need far less of these materials per unit. That alone disrupts demand forecasts, pricing models, and supplier contracts that were built on decades of assumptions. But Tesla didn't stop there. The 48-volt system allows them to redesign entire subsystems from scratch. Things like steering, braking, cooling, and suspension can be electrified more efficiently, eliminating bulky hydraulic systems and further reducing complexity. Fewer parts, fewer suppliers, fewer failure points, and tighter vertical integration, which is exactly how Tesla likes to operate. And this is why the move hits like a bomb rather than an upgrade. Because every supplier tied to the old 12-volt ecosystem now faces a brutal question. Adapter become irrelevant, wiring manufacturers, connector suppliers, control module producers, all of them have factories, tooling, and logistics optimized for a standard Tesla just walked away from. And when Tesla walks away, it doesn't do it quietly. It does it at scale, with speed, and with a kind of cost pressure that forces the entire industry to follow, whether they were ready or not. But the real shockwave extends beyond automakers into raw materials. Silver markets operate on tight margins and long-term demand projections. Even small shifts in industrial consumption can ripple across prices, mining investment, and geopolitical supply strategies if Tesla's architecture becomes the new norm, and history suggests it will. Because once efficiency and cost advantages are proven, competitors have little choice, then global silver demand models need to be rewritten. And that creates uncertainty, volatility, and opportunity all at once. This is why some analysts are calling it a silver bomb. Not because silver disappears overnight, but because the rules governing its use just changed, and Tesla triggered that change without waiting for committees, standards bodies, or industry consensus. They simply built the future they wanted and dared everyone else to catch up. And while most headlines focus on range, autonomy, or robotaxis, the real disruption is happening deep inside the vehicle where almost no consumer ever looks, because true revolutions don't always announce themselves loudly. Sometimes they arrive hidden behind engineering diagrams and wiring schematics. And by the time the world notices, the damage or the advantage is already done. To understand why this 48-volt decision is so dangerous for the existing supply chain, you have to zoom out and look at how deeply entrenched the old system really is. The 12-volt architecture isn't just a technical choice. It's an entire industrial ecosystem that has been optimized for decades. Entire factories are designed around producing thick copper wiring, heavy harnesses, relays, fuses, and connectors sized specifically to handle high current at low voltage. Suppliers invested billions into tooling, automation, and logistics networks that assume those material volumes will remain stable for years into the future. And suddenly, Tesla comes along and says none of that is necessary anymore. Because when you move to 48 volts, the physics change instantly. Power delivery becomes more elegant, energy losses drop, and the need for massive amounts of conductive material shrinks dramatically. Thinner wires don't just save material, they save weight. And weight is everything in electric vehicles. Every kilogram saved translates directly into better efficiency, longer range, or smaller battery packs. And batteries are by far the most expensive component in an EV, so even small reductions in weight compound into massive cost advantages at scale. This is where Tesla's strategy becomes clear. The 48-volt system isn't an isolated upgrade. It's a multiplier. It amplifies efficiency gains across the entire vehicle, and that creates a feedback loop where lower weight allows for smaller batteries. Smaller batteries reduce material costs, lower costs allow for more aggressive pricing, and aggressive pricing puts pressure on competitors who are still stuck with heavier, more expensive architectures, and that pressure flows upstream to suppliers who suddenly see demand soften for the materials they depend on. Silver is one of the most sensitive examples because it sits at the intersection of electronics, energy, and precision manufacturing. It's prized for its conductivity and reliability, especially in high current applications. But if current drops because voltage rises, the amount of silver needed per component can be reduced without sacrificing performance. Multiply that reduction across millions of vehicles, and you start to see why long-term demand assumptions become unstable. And markets hate instability. Miners plan projects decades in advance. Refining capacity is not easily adjusted, and contracts are often locked in years ahead. So when a company with Tesla's scale quietly shifts the equation, it creates a lag between reality and planning. And in that gap, inefficiencies and losses emerge, but Tesla isn't just reducing material usage. They're also simplifying assembly. Traditional wiring harnesses are some of the most labor-intensive parts of vehicle manufacturing. They're bulky, complex, and often require manual installation. With 48 volts, harnesses become lighter, simpler, and more modular, which aligns perfectly with Tesla's push toward automation and gigafactory scale production. Fewer manual steps mean faster build times, lower labor costs, and more consistent quality. And consistency is critical when you're producing at scale. This is another hidden shockwave, because suppliers who specialize in complex harness assembly now face shrinking relevance, while new suppliers who can support simplified high-voltage architectures gain an advantage. And this transition doesn't happen evenly. Some companies will adapt, others will fail, and the ones caught in the middle will feel the most pain. Because retooling factories is expensive, slow, and risky, especially when margins are already thin. Meanwhile, Tesla keeps moving forward, locking in cost advantages that compound year after year. And this is why competitors can simply ignore the change or dismiss it as a Tesla-only experiment. Once cost curves bend, they rarely bend back. And when consumers are offered cheaper vehicles with similar or better performance, brand loyalty becomes fragile, forcing legacy automakers to respond. But responding means re-engineering platforms, renegotiating supplier contracts, and absorbing short-term losses to chase long-term survival, all because of a voltage number most people never think about. And that's the brilliance of the move. It attacks the industry at its weakest point. Assumptions that were never designed to be questioned. And as this architecture spreads, it won't just change how cars are built. It will change who gets paid, who loses relevance, and who controls the future of mobility. Another layer of this story that makes the 48-volt shift so disruptive is how it changes the balance of power between automakers and suppliers. For decades, suppliers held leverage because standards were shared, components were interchangeable, and switching costs were high. If everyone used 12 volts, then suppliers could sell the same core technologies to multiple manufacturers, spreading risk and protecting margins. Tesla's move breaks that symmetry, because when you redesign the electrical backbone of the vehicle, off-the-shelf solutions no longer fit. Suddenly, components must be custom designed, software integrated, and tightly aligned with the vehicle's architecture. And that plays directly into Tesla's strength. Vertical integration. Tesla doesn't want to buy generic parts. They want systems designed specifically for their platform, controlled by their software, and manufactured at their scale. And when suppliers are forced to customize deeply, their dependence shifts. Instead of automakers competing for supplier capacity, suppliers compete to remain relevant to Tesla. And that flips decades of industry dynamics on their head. This is also where speed becomes a weapon. Legacy automakers move slowly, because every change ripples across dozens of partners, compliance requirements, and legacy platforms. Tesla can move fast because they control more of the stack, from design to manufacturing to software. So while others debate timelines, Tesla is already shipping vehicles built around the new architecture, gathering real-world data, optimizing costs, and refining processes. And once real-world data exists, theoretical debates end, because proof beats opinion every time. And that data advantage compounds just like cost advantages. The longer Tesla operates at 48 volts, the more optimized their designs become. And the harder it is for late adopters to catch up because copying the architecture isn't enough. You need the experience curve, the manufacturing lessons, the failure data, and the supplier relationships that only come from doing it at scale. And this is why the ripple effects extend beyond cars into energy infrastructure. 48-volt systems are already common in data centers, industrial automation, and renewable energy applications, because they hit a sweet spot between efficiency and safety. Tesla is essentially aligning automotive design with broader industrial standards, which opens doors for shared components, cross-industry innovation, and faster learning cycles. That convergence matters because it reduces friction between sectors that were once siloed, and again, that reduces cost. Now, circle back to silver, because silver demand doesn't just come from vehicles, it comes from electronics, solar panels, power systems, and industrial controls. When one of the largest EV manufacturers reduces per unit silver usage while simultaneously pushing architectures that align with other industries, it creates uneven pressure across demand segments. Some areas see efficiency-driven reductions, others see growth, and predicting the net outcome becomes extremely difficult, and uncertainty is poison for markets that rely on long-term planning. Investors don't like not knowing whether demand will rise or fall, miners don't like committing capital without clear signals, and governments don't like losing visibility into strategic materials. And that's why something as small as voltage can suddenly become geopolitical, because materials like silver are tied to national strategies, trade agreements, and supply security. And Tesla, intentionally or not, just injected noise into that system. But from Tesla's perspective, the logic is brutally simple. Reduce cost, reduce weight, simplify manufacturing, and increase control. Everything else is secondary. And this mindset is what legacy players struggle to match, because they're optimizing around existing constraints while Tesla is eliminating constraints entirely. And that difference in philosophy is what separates incremental change from true disruption. Most companies ask how to improve within the system. Tesla asks whether the system is still necessary at all, and when the answer is no, they don't hesitate to tear it down. And that's why the silver bomb metaphor fits so well, because the explosion isn't loud. It doesn't happen all at once, but once it goes off, the landscape is permanently altered, and anyone still standing on old assumptions finds themselves exposed, scrambling, and suddenly very aware that the future arrived without waiting for permission. What makes this transition even more unsettling for the rest of the industry is that Tesla didn't have to introduce the 48-volt system as a premium feature or a futuristic experiment. They treated it as an efficiency baseline, something so obvious in hindsight that it makes the old approach look wasteful. And when efficiency becomes baseline, it stops being optional. It becomes mandatory because competitors can't justify higher costs and heavier vehicles when a proven alternative exists. And this is where the pressure intensifies because adopting 48 volts isn't as simple as swapping a few components. It requires a fundamental rethink of vehicle platforms, electrical safety standards, diagnostics training and manufacturing processes. Legacy automakers are burdened by platforms designed years ago optimized around 12 volts and still amortizing their development costs. Writing those platforms off early is financially painful, but delaying adaptation risks falling permanently behind. And this creates a trap where every option carries risk. Meanwhile, Tesla continues to benefit from being early, because early movers don't just gain cost advantages, they shape standards indirectly. Suppliers start designing products with Tesla's architecture in mind, engineers entering the workforce train on these systems, and over time the new approach begins to feel normal, inevitable even. And once that happens, resistance fades. Not because doubts were resolved, but because momentum becomes overwhelming, and momentum is one of the most powerful forces in industrial change. Now consider the downstream effects on maintenance and repair. 48-volt systems allow for more intelligent power distribution, more precise control, and fewer mechanical linkages, which means fewer wear components and potentially lower maintenance needs. That's good for consumers, but disruptive for service networks built around traditional mechanical systems. Less maintenance means less revenue for dealerships, and service providers further weakening the old ecosystem while strengthening manufacturers who rely on software updates and centralized control. And again, this ties back to materials like silver, because reduced wear and fewer replacements also mean reduced recurring demand for certain components over a vehicle's lifetime, shifting revenue models from parts to software and services, a transition many companies are not culturally or structurally prepared for. And this is why the real story isn't about voltage at all. It's about leverage, control, and who captures value in the next phase of mobility. Tesla's architecture choices consistently move value upstream toward design and software, and downstream toward scale and automation, squeezing the middle where traditional suppliers operate. And when that squeeze happens slowly, companies can adapt. But when it happens quickly and at scale, adaptation becomes survival, and survival becomes selective. Not everyone makes it through. History is full of examples where industries clung to standards long after their expiration date because change was inconvenient, expensive, or politically difficult, and every time, the companies that moved first rewrote the rules, while the rest argued about fairness, compatibility, and transition timelines. And by the time consensus was reached, the market had already decided Tesla understands this pattern deeply. They don't wait for consensus. They create facts on the ground, and facts force reactions, not discussions. And as more vehicles roll off production lines built around this new electrical backbone, the idea of going back becomes unthinkable. Investments follow certainty, talent follows opportunity, and innovation follows momentum. And all of that accelerates away from the old standard, leaving behind a trail of stranded assets and outdated assumptions. And this is why the so-called silver bomb doesn't explode once. It keeps detonating in waves, each wave hitting a different part of the ecosystem. Materials, suppliers, manufacturers, service networks, and even regulators, and each wave makes the next one stronger, because systems under stress are less resilient. And when the final wave hits, the industry looks around and realizes the transformation didn't happen. Suddenly, it happened quietly, step by step, while most people were looking somewhere else. At this point, the most important question is no longer whether the industry will follow Tesla's lead, but how painful that transition will be for those who waited too long. Because once a technological shift proves cheaper, lighter, and more scalable, resistance becomes irrational, and markets punish irrational behavior quickly. Automakers that delay will face a double penalty, higher production costs internally and lower pricing power externally. And when margins compress, something always breaks, investment slows, innovation stalls, and talent migrates toward companies that are building the future rather than defending the past. And this is why Tesla S 48-volt move feels less like an upgrade and more like a trap door opening beneath the industry, because it forces decisions that many players were hoping to postpone for years. And postponement is comfortable until it becomes fatal. Now, zoom out one last time and look at the bigger picture. Transportation is undergoing one of the largest transformations in history. Electrification, automation, software, defined vehicles, and energy integration are all converging at once. In moments like this, small technical choices can have oversized consequences because they either align with the direction of change or fight against it, and Tesla's choice aligns perfectly. Higher voltage supports automation, reduces material dependency, improves efficiency, and simplifies manufacturing, all of which scale beautifully in a world moving toward mass electrification. And when something scales beautifully, it wins. Not because it's flashy, but because it's inevitable. And inevitability is what truly scares incumbents, because you can't argue with it, you can't market your way around it, and you can't regulate it out of existence without hurting yourself in the process. And this is why the silver bomb metaphor lands so well, because the explosion isn't about destruction, it's about exposure. It exposes inefficiencies that were hidden by tradition. It exposes cost structures that no longer make sense, and it exposes which companies are built to adapt and which are built to defend. And in that exposure, winners and losers become obvious. Tesla didn't announce this move with dramatic press releases or grand promises. They simply engineered it into their vehicles and let the numbers speak. Lower costs, lighter designs, faster assembly, and tighter control. And numbers have a way of ending debates quietly, because once spreadsheets change, strategies follow, and when strategies follow, entire industries pivot, often faster than anyone expected. And this is the part most people miss. Revolutions don't always look like revolutions while they're happening. They look like minor optimizations, technical footnotes, engineering choices buried deep inside products. And then one day, everyone looks up and realizes the ground shifted beneath them. And there's no way back. So as you hear more about batteries, autonomy, and futuristic designs, remember that some of the most powerful changes are invisible, hiding in things as unglamorous as voltage levels and wiring diagrams, because that's where costs live, that's where scale is decided, and that's where real control is established. And if you want to understand where the automotive industry is headed next, don't just watch the headlines, watch the infrastructure, because that's where the future is being locked in right now. And if you want to stay ahead of these shifts, make sure you keep watching the next videos we've lined up for you. Subscribe to the channel, stay curious, and don't miss what's coming next, because the quiet changes are the ones that matter most.